All right, let's dive into a topic that is totally reshaping medicine as we know it, artificial intelligence. And this isn't some far-off sci-fi concept. Nope, it's here, right now, and it's already making life or death decisions.
So let me just start by asking you this, straight up. Could a piece of code, a simple algorithm, be the thing that saves your life one day?
Well, the thing is, it's not a could be. It's already happening. But as this whole revolution takes off, we're kind of in a race to write the new rules of the road and answer some really massive questions about safety, fairness, and, trust.
So before we can even begin to talk about writing those new rules, we first have to get a handle on what's actually happening. What does it even mean when we say AI is in the doctor's office?
You might think this is all just an overnight thing, but the truth is, AI's journey in medicine goes back decades. I mean, the term artificial intelligence itself, that was coined at a conference all the way back in 1956. By 1972, we had a system called MyCin, which was designed to help diagnose infectious diseases. And the very first FDA approval for an AI-powered medical device. That was way back in 1995.
So what are we really talking about here? Well, the official US government definition basically says it's a machine-based system that can make predictions or decisions that affect our health. It's best to think of AI as a big umbrella term for all sorts of technologies that are designed to learn from just massive amounts of data in a way that our human brains, well, they just can't. And how it's being used today pretty much falls into three main buckets. First up, the big one, diagnosis and treatment. This is like an AI analyzing your MRI or CT scan, spotting things a human eye might miss. Then there's patient engagement. Think of a smart tool that helps monitor your recovery while you're at home. And third, you've got the administrative stuff. Not as glamorous, I know, but super important for streamlining things like billing and medical records.
Okay, so that's the big picture. But to really truly grasp the power of this technology, let's zoom in on a real-world case study, an AI that can diagnose skin cancer.
This image just perfectly captures the problem, right? A dermatologist has to look at a spot on your skin and figure out what it is from literally hundreds of possibilities. You're looking at this huge, complicated decision tree, where one path is a totally harmless mole and another path is a life-threatening melanoma. I mean, the stakes just could not be higher.
So to try and solve this, researchers took what's called a deep learning algorithm, which is a type of AI that's kind of inspired by the neural networks in our own brains. And they basically sent it to medical school. They fed it a massive visual library of more than 125,000 images of skin conditions, all of which had already been classified by expert dermatologists. We're talking over 2,000 different diseases.
And the result? Honestly, it was stunning. This graph here shows you the AI's performance in blue against actual board-certified dermatologists in red. And as you can see, the AI performed right on par with the human experts at spotting potential cancers. It was just as good as doctors who've spent their entire careers training for this one exact task.
And get this, when it came to one of the most critical tasks, telling the difference between the most common types of skin lesions, the algorithm hit an accuracy of 72.1%. And the two human dermatologists it was up against, they scored 66%. The machine was actually more accurate.
In AI that can outperform a doctor at diagnosing cancer. I mean, that's absolutely incredible. But that kind of power is exactly why this next question is so critical. Who is building the guardrails to make sure all of this is being done safely and ethically?
Well, there isn't one single AI regulator. It's more like a team effort. You've got the Office of the National Coordinator for Health IT, or ONC, and they set the basic rules for how data is handled. Then you have the FDA, who's like the gatekeeper, deciding if an AI tool is safe enough to be used on patients. The Office for Civil Rights jumps in to make sure these tools aren't discriminating. And finally, the folks at Medicare and Medicaid decide the rules for how doctors actually get paid for using them.
And to help guide all this work, these agencies are starting to use a set of principles, which have this handy acronym, FAVES. Really, they're just asking 5 common-sense questions. Is the AI fair so it doesn't make things worse for certain groups? Is it appropriate for this specific job? Is it valid, meaning, accurate? Is it effective out in the real world? And above all, is it safe?
And that FAIR principle, that is a huge one. The Office for Civil Rights has a specific rule that says you can't use AI to discriminate against patients. This is so important because the last thing we want is for the historical biases that already exist in our healthcare system to get accidentally baked into the code and then basically put on steroids. Look, these rules are a fantastic start, but they're really just the beginning. Because once you look beyond the code itself, you find these deeper, much more complicated challenges that, frankly, we're all still trying to figure out. It's really a double-edged sword. On one hand, the promise is that AI can make purely objective, data-driven decisions, but the peril, that same AI, trained on our very human, flawed data, can accidentally absorb and even amplify our worst biases. The promise is finding these incredible hidden patterns, but the peril is what's called the black box problem. The AI gives you an answer, but it can't explain why. And for a doctor who has to justify every single decision, that's a massive barrier.
And this leads to some huge unanswered questions, like who actually owns the medical data that these powerful models are trained on? How do we protect our privacy? If an AI makes a mistake, who's on the hook legally? The programmer? The doctor? The hospital? And maybe the biggest question of all, how in the world do we build public trust in all of this?
Because right now, that trust just isn't there. A recent Pew Research survey found that 60% of Americans, a clear majority, would be uncomfortable if their own doctor relied on AI to help with their care. And it doesn't matter how good the technology gets. If people don't trust it, it will never reach its true potential.
Okay, this brings us to our final and maybe most important idea. What if this entire conversation we're having about data and algorithms and trust is missing a massive piece of the puzzle? What is AI's biggest blind spot?
It's this. Research shows that for a whole host of diseases from cancer to autism, the environment we live in, the air we breathe, the water we drink, the chemicals we're exposed to, that actually plays a bigger role in our health than our own genes do. And yet most of our health data projects and AI models, they are almost exclusively focused on clinical data and genetics, pretty much ignoring this giant data set about the world around us.
And that leaves us with this final thought. We are building these incredibly powerful digital minds, capable of seeing patterns that we can only dream of. But are we pointing them at the right problems? As we build them, are we asking them the right questions about our messy, complicated analog world? That right there might just be the most important question of all.